Thank you for joining us today. I am Brian DeLuca along with Nicolette Amino. We're your hosts for today's live chat, Risc-V, Designing the Future. I want to thank our sponsors, Mouser Electronics and Microchip. We have some great panelists, and this is a live discussion, everyone. So in the bottom, you will see a Q&A. Make sure you ask your questions there because you have the chance for these awesome panelists to actually answer some of your questions directly. And now to Nicolette.
All right, thanks, Brian. Now, before we get started, let's introduce our panel. Thank you guys for joining us today. We've got Josh Lifton, co-founder and president over at CrowdSupply, Mark Himmelstein, CTO at Risc-V International, and Tim Morin, technical fellow marketing at Microchip. And I just want to mention that Ted Spears wishes he could be with us today, but there is an Arctic freeze down in Texas, so he will not be with us today, and Tim will be joining us instead. So thanks for jumping on, Tim. We really appreciate that.
Sure.
So why don't we kick off Risc-V? Let's get started by looking at sort of the importance of Risc-V and why it's growing in popularity. Let's have Mark kick us off. Why don't you give us a high-level overview on that topic? Really, why is Risc-V important? You know, what's the state of adoption? What is this all about?
Sure. Thanks, Nicolette. It's an interesting phenomenon. I mean, I think that Risc-V is the first chip of this magnitude that was born and grew in open source. And so just like Linux did this, Risc-V is doing this. So there's not only a lot of great technology in it, but there's also a lot of pride of ownership and community effort and involvement in it. So that alone makes it very attractive. But then, you know, we've reached a point in the world where, you know, we have a lot more technology to develop and deploy, you know, chips very quickly. Especially over the last 15 years, there's kind of a renaissance in this stuff. And so people want to go ahead and target a specific application, and therefore they want to customize, and Risc-V gives you that ability. The basic instruction set's 47 instructions. You can just do that. You can concentrate on what you're good at. So we like to say, innovate, don't duplicate. And that's what the community gives you. You don't have to worry about all the basic stuff that's been done 1,000 times before. You worry about the stuff that you care about. You know, if you're doing a low power application, or you're doing something specific to AI and ML or embedded or HPC, you can concentrate on the things that you care about. And you asked about adoption, and really, adoption is a very interesting story because it's not as much dependent on the chip as it is on the product. So different products take a different amount of time to go ahead and get out to market. So, you know, a disk drive, a year and a half, a car, 3 to 5 years, a server, more towards 5 years. You know, development boards, you know, probably closer to a half a year or a year. And so you're starting to see a lot more embedded boards and development boards and embedded situations because they have shorter runways. And so, you know, you'll probably see in the hundreds of millions of cores in the next 3 to 5 years. You know, it could be higher. We tend to try to be conservative. But, you know, we're excited about, you know, it being developed, you know, for all applications. So, you know, embedded, you know, controllers, automotive, you know, motors, wire, you know, cellular, network edge, cloud servers, you know, data center servers, HPC, and so on. So there's probably no piece of the computer, you know, broader computer industry that isn't, you know, getting involved with Risc-V, at least kicking the tires, but many going ahead and developing products.
Thank you, Mark. Tim, Josh, did you guys want to talk about, you know, kind of why Risc-V is becoming important in your eyes as well? I don't know if you wanted to add anything to that.
Yeah, I guess I'll go first if you don't mind, Josh. So, you know, why is Risc-V important? I kind of echo Mark's comments, you know, choice and freedom, the freedom to innovate. And, you know, I think there's a natural tendency and curiosity for engineers to try to, you know, invent things, create new things, do things a better way. And the open source community kind of led that way with Linux. Now, that doesn't mean that Risc-V cores are going to become open source per se. You can just download a whole bunch of, open and free cores. You'll have some of that, but there's also companies out there innovating and delivering, fully verified IP for, chip manufacturers like Microchip for us to actually integrate into our products. And so we're kind of leveraging that whole spirit of open source and creativity, and then feeding that back out in the market with products that people can develop on top of, and continue that ball that's kind of like rolling downhill and ever faster rates. So choice and freedom, I think, are the hallmarks of what Risc-V is all about.
Yeah, I completely agree with that, and what Mark said as well. It's kind of the pendulum swinging back in a way from computing started with personal computing started with homebrew computers, and you were designing hardware at the transistor level to do exactly what you wanted. Then we moved to kind of general purpose CPUs, and decades of that. But now we're starting to return to that initial homebrew stage, but now with way better tools, right, and with better resources, and Risc-V being one of those kind of foundational layers there, where individuals or small groups can really and compete with the best in the world. And that's what kind of the story of open source and Risc-V, and that's how we're kind of seeing that play out at Crowd Supply anyway.
So, Mark, we've spoken to you a couple times before this, and you've mentioned this before. Why is Risc-V an architecture for the next 50 years, as Dave Patterson says? Where is it used? Why is it used? We talked a little bit about the importance, but what is that architecture for the next 50 years? What is that all about?
Yeah, one of the things we got was the benefit of our place in history. We stand on the shoulders of giants, x86, ARM, MIPS, Alpha, PPA, Power, Spark with the C. And so we got to see all that. And then, as Krista, who's kind of the godfather of Risc-V, was starting to do something for a particular application he cared about. He realized he didn't have an instruction set that was flexible enough to do what he wanted to do. And so, they created Risc-V, and they did it in a sort of a very interesting way, a very flexible way. They created these extensions. So the base set is 47 instructions, but there are extensions to do everything, and you can pick and choose which ones you want, and you can go ahead and create custom ones. And the reason why we believe it's really geared for 50 years is, number one, you can pick the pieces you want, you can add pieces. So 20 years ago, we wouldn't have had stuff targeted towards AI and ML. It just wouldn't have been there. It would have been databases probably more, and not AI and ML. And so today, AI and ML are important. So we have pieces of our extensions that are targeted towards that specifically, and help that out specifically. I don't know what's going to be in 10 years. So you need an architecture that you can add extensions into in 10 years for what's important in 10 years from now. And Risc-V is really, really set up that way. And just in general, you get to pick and choose. So if you're in an embedded application and you don't want a divider, because divides are kind of, take up a lot of room to implement, you can just go ahead and do the integer, addition and subtraction. You can go ahead and do a custom thing with just the multiply piece of our M extension, which has multiply and divide, and get what you want. That, plus the ability to add extensions later for whatever is important, is the hallmark of what makes us set for the next 50 years.
So some of you mentioned the community multiple times in this. So how important? What is the role of the open source community in Risc-V?
You want me to take that again?
Yeah, go for it, Tim.
Go ahead, Mark.
You
Well, all
mentioned
right. So
open
I
source.
think Mark kind of reiterated that earlier. Is like, all these working groups that are part of the Risc-V Foundation, everybody's contributing this, with their own, sweat and blood. and that's where the community comes from. Okay. And as Mark mentioned, we're standing on the shoulders of giants. A lot has been gained over the last 30, 40 years in the semiconductor industry, and we're kind of leveraging all that. And so this spirit of cooperatively working together to make the instruction set simple, make it complete, and leave plenty of opcode space available for customization, that's an engine for innovation, and that'll fuel growth for the Risc-V ISA easily, I think, for the next 50 years.
Yeah, and I think, we have over 230 strategic and premier members, which are, corporate or institutional members. We have over 1,000 individual members. And I will tell you, I'm really impressed when you go to those meetings, the amount of intellectual power, experience, and I think camaraderie is just astonishing. And that's what community is about, right? And again, our whole goal is to allow people to innovate. We want people to make money. I mean, we're a nonprofit, but the idea is to give people the power to make money and have products, whether it be software services or compilers or chips or IP or whatever it is. We want them to go ahead and proliferate, Risc-V cores and have them enable, the economy of these companies. But in the end, it's these great scientists who are in these rooms contributing as a community that make Risc-V really great. And I've never seen something at this level in the open hardware world ever occur before.
Yeah, I think it's a pretty smart play by kind of bigger companies like Microchip, who are bringing in these individuals and small groups, because you're gaining so much just perspective, right? Because they're not going to know sitting in their own room what the rest of the world wants. They need to talk to the rest of the world, and that's what open source is bringing. One of the things it's bringing to the table right now.
Yeah, and everybody gets a sense of ownership. I put my mark on history by participating in the Risc-V, Foundation's activities, and really, people make things better for other people. And so there's that camaraderie and sense of ownership and esprit de corps that exists in these meetings. If you've never been to a workshop or never been to the summit, I encourage everybody to go to these things, because it's a great place to meet some really, really smart people.
Well, while we're on the topic of open source, why don't we talk about the difference between open source hardware and open source software? Mark, I don't know if you want to give us that differentiation.
Yeah, absolutely. And this was a little bit of an epiphany for me after I've been with Risc-V a little over 8 months. And, I had the epiphany fairly quickly. In the open source software world, if you're working on Linux or Hadoop or, Apache or whatever, you're working on the product that your company's selling, right? It's actually the thing that your company sells. I've had, as a manager, had people working on Linus's team on the kernel. And so, we wanted the kernel to have certain things, and they helped get those things done. And they spent some portion of their time helping us make sure it worked on our hardware product, but they were working on the same bits that they went ahead and shipped out. That's not true in the hardware world. In the hardware world, the same people who are designing the ISA are the same people who later have to actually build a chip or IP, and later have to go ahead and actually put it into a product. Like it's got to end up in, a controller or an automobile or something. And it's the same people who are working. So there's a lot of contention for those resources. And that was a really big epiphany for me. The other thing to note is there aren't that many people in the world who can design ISAs. And so each company maybe has 1, 2, 3 kind of people. And so we're drawing from all those people. And so there's a lot of contention for their time. So one of the things we did as Risc-V International is we try to split out the work that architects have to do from the work that developers have to do. So, whether it be the software ecosystem or, proof of concepts or architectural tests. And then we've engaged a bunch of what we call today group contributors, or some fancy marketing name that's coming, But we have institutes around the world who are helping us get that work done, freeing up the architects to do architecture work.
So there's a question that I think a lot of people have out there, and I have a feeling, we're starting to get some questions in, but I have a feeling this is going to be one that comes up. So let's talk about the comparison, because a lot of questions people have are around, why Risc-V as opposed to MIPS or ARM or whatever, anything. And I think, Mark, you talk about this a lot. You have a great response to this when we talk about comparisons. Why don't you tell us about that?
Oh yeah, absolutely. And feel free, the other folks, to jump in as well. We have an attitude, again, that we stand on the shoulders of these folks, of all these other technologies. And so, first of all, we're very grateful to them. Also, if you take a look at the architects, where did they cut their teeth? Where did they learn the business? They learned it in those other architectures. So, almost everybody who's helping us design the ISA either worked on x86 or ARM or MIPS or Power or Spark or something. And so we're very, very grateful. The second thing is, we believe in competition. We think it eggs on technology better, right? So we want more than just Risc-V out there in the world. We want other technologies, because they're going to break new ground and they're going to force everybody to play a better game. And then finally, there's a lot of reasons why you might use one chip versus another chip, and people have to make their own decisions. Sometimes it's legacy because you've been doing it for a while and you have all the infrastructure in place. Sometimes because it's the application seems to be better targeted towards that. We support all that. We're happy with all that. We talk to the folks at Intel and Lenaro, and we have a lot of presence at our conferences, and I think there's a lot of engineering camaraderie. One of the things about open source, to go back to that, is it breaks down the barriers between countries. It breaks down the barriers between companies, and so we're part of a greater CPU computer community, and we're glad to have them existing in the world.
Yeah, I have a interesting perspective on this. I actually may be the only person on the planet that was around, that worked for a company that introduced the first ARM7 TDMI standard product, a product you can buy a quantity of 1 or 10 million. And, maybe working for a company, Microchip, that introduced maybe the first standard product for Risc-V called PolarFire SoC, that you can buy a quantity of 1 or 1 million. There, I think, might have been like a 20-year delta in time, over that period of time, and if you think about it, prior to, the ARM introduction, it was probably 20 years before we saw, ARM come into the market from the previous instruction set architecture. And it came into the market for a reason. It was solving a problem: low power and mobile handsets. And so, I think the competition is going to be there for a while. I think it's going to be good. There'll be many chips with Risc-V and ARM side by side. I'm not overly concerned about that. Competition makes you think harder, puts you in a box, makes you want to get out of the box, and those are all good things. And the interesting thing about Risc-V is that you're in the box with a lot of other people from a lot of different companies around the planet, and we're all helping each other to try to get out of that box. So I think it's all great for everybody in the industry, and I think it's going to reinvigorate life into the semiconductor industry for quite a long time.
So that's a really cool way to look at it. Actually, I was thinking about asking you, Josh. What about your audience? What's drawing the crowd supply audience to Risc-V?
Well, this is Risc-V is one of the endpoints on the trajectory of taking a software developer, of which there are many, and you can do that from anywhere, and turning them into a hardware developer where there's relatively few, and it's a more rarefied skill set, and you need more rarefied resources, right? And so that trajectory kind of started with FPGAs and turning hardware into a software problem. And I think Risc-V is like I said, one natural endpoint there. And so a lot of talented people who maybe don't have really long histories in hardware are now getting into hardware because of Risc-V, and starting to make products and innovate in that way, right? Going back to the previous question about the difference between open source hardware and software, from where I sit at Crowd Supply, where we deliver products to people, it's atoms versus bits, right? It's expensive to ship something across the world or to make it. It's relatively cheap to send bits, and so there's a whole different economics around open source hardware, and I think we're still trying to crack that nut. But there's a whole bunch of people now paying more attention to it. So I suspect that a lot of progress will be made very shortly, and has been made already.
So we do have some questions rolling in from the audience. I think let's pivot. Here we go. We have a question. How long before we see Risc-V SoCs and mobile processors? Would this be able to impact the mobile device market? I'll throw that out there, whoever wants to grab that.
Yeah, so we do know that there are members who are working on both sides of 5G and the mobile device and the servers that support them. We Risc-V don't announce for our members. We know that they're doing this stuff because they bring some of the requirements to the table, and that's how we understand that. But I think you're going to see stuff, fairly, in relative time, fairly soon, with handheld devices that include Risc-V.
Can I ask you a question, Mark, related on that topic? When will the J instruction extension be ratified, do you think, in your opinion?
So, so first of all, so for the audience, we have for some of the key extensions, they got to get major alphabet names. so I is addition, subtraction, load, store, blah blah blah. M is multiply, divide. A is atomics. C is compressed. J is really meant to support just in time, runtime compiled items. And so there are pieces that are in J that are going to have extension names that aren't, particularly J. So most of the extension names now end up with a Z if it's a unprivileged instruction, so a user level instruction, and the other is S if it's more of a system level instruction. So all the virtual memory things will have S with some string after it, and all the unpriv stuff tends to have a Z. So for example, bit manipulation has ZBA, ZBB, ZBC, ZBS, ZBK. And so there is, pieces of J that will come to market, become ratified fairly quickly. In particular, one of the things they're working on right now is, instruction and data synchronization. So when your just-in-time compiler, writes some new instructions it wants to execute because it did compiled some Java program. You need to go tell the machine that you've done that, right? Because otherwise you may have stale stuff in your cache and you'll get the wrong result. And if folks want more details on this, there's lots of details we can give offline. I don't want to go too much into technology, but they're going to be close probably towards sending this through. And the other thing we've done is we've created a fast track program for small instruction sets, small instructions. And so the first one that went through is a thing called ZI hint pause, which is meant to allow programs to tell the CPU that they can power down and use less power. And it's really important for mobile devices. It's important for embedded. And so there's probably somewhere between 7 and 14 of those going through this year. And ID synchronization may be part of that, or it may be going through with another set of things. I don't think we've totally decided that yet. But one thing we're doing this year that we've never done before is we're setting out a roadmap for the year of all the extensions, the full extensions and the fast track extensions that we're planning to get ratified this year. And we're going to have a name for it, the same way you have like, ARM v8 or Xeon this or whatever. We will have Risc-V, so RV, A for application, so that's something that's at the Linux level, or M for microcontroller, so bare metal or RTOS, and then RVA 22. And so there will be a set of extensions that are ratified, either ratified before, like in 2019, or ratified this year in 2021, that will be part of RVA 22, and they'll be either required, optional, unsupported, or incompatible. And so, so we have, you know, this is the first time we're doing a top-down plan, right? Because everybody knows when you do design, you got to do top-down, bottoms-up. We've been doing a lot of bottoms-up because we knew there was low-hanging fruit that we had to do. Now we're a little more sophisticated. We're growing as an organization, so we're doing top-down. And so, you know, so Jay get ratified this year. I can't speak yet for all of it, but parts of it will definitely be coming through this year.
Yeah, thanks. The reason I asked is that, you know, I saw some reports recently about, you know, some Android running on some Risc-V hardware. Somebody supported a JVM, which is, you know, that plus the J extensions getting ratified and completeness, you know, is probably a harbinger of things to come for mobile, is, you know, my personal opinion.
Yeah, and there's a couple of institutes in China that have been working on both Chrome OS and Android, and they're making very, very good progress. And so, you know, watch this space, and we'll definitely give you more information as they become available.
So we have another audience question. Speaking about, like, you know, some of the things we're talking about now, but what kind of hardware and software tools would a small startup require to begin developing a Risc-V processor or IoT and AI applications?
So, you know, I can speak to it, but, you know, obviously, you know, Tim's got a whole customer base that's working with their products, and I'm sure that, you know, he can provide some stuff. I know some of the tools they're using, but we try to support, you know, both open source solutions to those things, and some of them are done by sister organizations that are nonprofit, as well as our, you know, our proprietary commercial members and their availability. So at risc5.org, we have a thing called Exchange, where anybody can freely advertise their Risc-V based product, whether it be a service, you know, a tool, a chip or IP technology or a board, and so there's really a great way for people to find those things. I'll also mention that there's these groups, Open Hardware, Low Risk, Chips Alliance, that are actually doing free to use designs with full DV and everything else. So depending on what you do, you might go one of those paths, or you might go to someone like Microchip and get their help, or any of the other you know, vendors that are out there. And I think it really, I mean, the cool thing is it depends on what you're going after, right? Because a lot of people are targeting helping specific deployments, specific workloads, and so there's a lot of variety out there. And again, you can start with open source, you can move on to something commercial, and you know, we're all here to help you be successful. Tim? Yeah,
it just depends on what you need. I mean, we do have something called PolarFire SoC out in the market. We sold our first kit, the Icicle kit, through Crowd Supply. We actually were oversubscribed and overwhelmed with demand. There is inventory in the channel now, so if you wanted to like try Risc-V and learn how to use it, you can buy that kit and get started today. We have a GitHub site. We've got a Linux, you know, a build root project. We have a Yocto project. We have bare metal projects. We're going to be releasing Zephyr pretty soon. I mean, we've got Wind River has a BSP for it. Mentor Nucleus has a BSP for it. So, you know, we've been rolling out, you know, a specific ecosystem around PolarFire SoC, so customers like you can actually do something with it. And so just Google PolarFire SoC Icicle kit, and you'll see tons of information to get you started.
Yeah, and I'd say that is right now the premier SBC, and insofar as SBC means you can run Linux on it. The PolarFire SoC Icicle kit is leading the charge right now, I'd say.
Well, it looks like you answered one of our attendees' questions, because they were asking which upcoming Risc-V SBCs do you recommend to follow? So I'm guessing this one's up there, right, Josh?
Yeah. I mean, you can do other things. You know, soft cores elsewhere, but as far as like if you want to talk to the world and have peripherals and things like that, then the Icicle kit is the way to go.
So, we talked a little bit about the PolarFire, and Tim, I didn't know if you wanted to bring up a little bit more about Microchip's role, in Risc-V and the adoption. Maybe you want to talk a little bit about that.
Yeah, so we talked earlier about innovation, being in a box, being competitive and having competition. So I work in the FPGA business unit at Microchip, and Xilinx and Altera are like number 1 and 2 in the market. And I think we're number 3, and so we're always having to innovate. I mean, to be honest, it's very it's easy for them because they just make the biggest, fastest chips on the most expensive node possible. Okay, but we have to innovate. Okay, we have to find out, specifically, where we can provide solutions to our customer base. And back in it was 2015. Ted, who can't be here right now because he's freezing in Austin, sent me a link about Risc-V, and I looked at it, and I was like, wow, this could solve a lot of our problems, because for an SoC FPGA, it's a little bit different than just a standard SoC. We have to serve 10,000 different applications. So the problem space we're trying to optimize in is 10x, 100x that over a specific SoC. And, looking at the market and trying to acquire IP that would try to serve all those application spaces, we just weren't being met. Okay, so the Risc-V, everybody talks about the technology behind it, but there's a lot of business innovation as it relates to Risc-V. It opened up the door for us to help solve some customer problems that we couldn't solve any other way. So that's kind of how we got started. We're pretty excited. We went to some of the original Risc-V workshops in Berkeley, and we've been, building out our ecosystem to support the broader ecosystem, and very happy with the results so far.
Yeah, let me just also use Microchip as a poster child for involvement in Risc-V. Ted is on our board, and he helps us. He was the first guy who interviewed me. So I've been very grateful for his mentoring and his involvement. But for example, to sort of answer one of the other questions I see in the Q&A, the gentleman who runs the crypto group, so CryptoScaler, CryptoVector, is a Microchip employee, Rich Newell, and he's just one of those people where I said the power of the intellects in those rooms are amazing. He's one of those people. And so Microchip not only is helping us by selling a good product and making things available for customers, they're also helping us advance the whole of Risc-V's architecture and ecosystem, and we're grateful for that.
So you mentioned one of those questions there, Mark. We do have a question about security, right? And so keeping in mind the growing threats to hardware and SoC devices, how secure is Risc-V hardware and, against hardware attacks like side channel hardware fault injection and other hardware Trojans?
So first of all, I want to say, there's no free lunch, right? So if you want to protect your stuff, it will cost you logic and other things in order to get it done. And so everybody has to make a decision about how much security they want in their implementation. But we've developed a system called horizontals, where these are things that go across all the extensions. So security is one of them. RAS is another, reliability, availability, serviceability is another. Implementation, so there's a whole bunch of those things in the software, and they all have to sign off before something gets ratified. The security horizontal committee is very powerful and has helped us, plot this course. I mean, obviously there's always unending things, but, number one, they're there to review stuff to make sure nobody's putting something in that is, obviously attackable especially, you know, Spectre, Meltdown, all those kind of things. We know all that stuff now. And again, we had the benefit of history. In my background, so I ran Solaris. I also ran Trusted Solaris and all our PKI stuff and so on. And we open source PKI back then. So I'm very familiar with this stuff. We have a group that's doing trusted execution environments. They have, you know, 3 extensions that will probably get ratified this year and probably 1 next year. So that stuff is being worked on. And then we did something really innovative with crypto. We have, we split crypto into vector and scalar. Vector is sort of the standard way you do things like AES 128. And we had a gentleman from Bristol, you know, encourage us to split it out. And so we're able to get the crypto scalar done even more quickly. So it will for sure be done this year. The vector may or may not make it. I can't tell you right now one way or the other. But we also have a security response team that goes ahead and deals with CERT and all that kind of stuff at the ISA level. We have somebody about to come in and start a blockchain SIG. So, you know, to make sure that the ecosystem to support blockchain well, you know, through the crypto instructions, through trusted execution, through the software ecosystem is all taken care of. So we have a group that's dedicated towards security. And again, I've gone to those meetings and they're very sophisticated and they're very dedicated. So I think we're in good shape. If somebody wants to go ahead and implement something that's secure, we have a roadmap and we have a path for them to implement as secure a chip as they want to do.
We actually have another question here specifically for you, Tim. Tim, is it possible there could be lower cost Linux capable microchip parts with Risc-V cores? Maybe something like SAMA 5, but with Sci-Fi U54 or U74. Drew mentions here he likes the PolarFire SoC, but the presence of FPGA makes it more expensive than necessary for use cases and does not require programmable logic.
Hi, Drew. So the answer to that question is that business unit, you know, has the ability to, you know, take what we've done and, you know, make a SAM-like product with a Risc-V processor. There's no restriction on them doing that. Do they have that in their roadmaps? You know, I really couldn't speak to that. Even if I knew, I probably couldn't tell you. But I think the same conditions that exist for a lot of companies on this planet and a lot of divisions within large conglomerates, you know, exist for everybody. And that is, you are going to constantly have to innovate to stay alive. You know, only the paranoid survive in the semiconductor industry. And if you're not paranoid, you're probably on your way of going out of business. Yeah, I think that's the best way to answer it. I mean, I think the FPGA business unit is becoming kind of like the Risc-V Center of Excellence for Microchip, and we'll continue to promote Risc-V where applicable. We do use, you know, small little Risc-V cores in, you know, that are not, you know, visible to the customer in other chips and other business units. Okay, so just, you know, and there's actually a parallel to that, to how ARM kind of, you know, grew the market. When we first introduced the ARM 7 TDMI back in my previous company, you know, you could buy ARM cores and integrate them into an ASIC, but that's it. Okay, you couldn't buy standard products. Then all of a sudden you had a proliferation of standard products and anybody can buy it. You know, it's ARM for the masses. So Risc-V is getting to that point. Everybody's using, you know, cores inside ASICs, or they're using cores inside ASSPs where their customers are completely hands-off and a complete solution is delivered, including the software stack. And, you know, I see that corollary happening with Risc-V, but I think it's going to happen at a much, you know, faster rate.
Thanks, Tim. We have another question here from the audience. Could emerging AI chip placement and floor planning EDA software be used to shorten Risc-V implementation from design to Foundry? Anybody want to jump in?
You know, I think it's a leading question, and the answer is yes, of course. You know, we don't at Risc-V, you know, do DV or layout or any of those kind of things, and we rely on our commercial members and institutional members and organizational members, and some of them nonprofit as well. to drive that stuff. But you know, this, I mean, even without what this person asked, the time between deciding to make a chip and actually having a prototype in your hand is really small. We have some kid in India who was 13 years old who made a Risc-V chip. We have 4 undergraduate students in China who spent $12,000 in 4 months and made a chip. And they're moving towards a system, 1 student, 1 chip, that's going to be required before you pass through undergraduate. So the tools that enable that have just really experienced an incredible renaissance over the last 15 or 20 years. And I think one of the reasons why Risc-V is going to be successful and is successful as it is because of that infrastructure.
Thanks, Mark. So Josh, I want to ask you, in your opinion, what do you see as the next milestone in Risc-V adoption?
Well, yeah, I think the Icicle kit was the most recent milestone, right? Kind of something that you could boot Linux on and make a desktop computer, basically. I think the next one is further down that path where yeah, you have a laptop that has a Risc-V processor on it, and you know, it's not going to compete necessarily with you know, the ones we're using in front of us right now, but it's still perfectly serviceable. You could run a web browser on it. You could you know, have a nice laptop, and that is I consider that a milestone simply because once you get those chips into people's hands and they're using them every day, and it's not just, you know, what I call shelfware, not just sitting in your closet and you bring it out occasionally, but you're using it every single day and you're developing software on it and you're interfacing other peripherals with it, then we'll see that kind of renaissance that we've been discussing and hoping for, I think, in terms of adoption.
No,
but maybe other folks have other milestones in mind.
Well, I mean, I think somebody asked a question earlier about mobile, right? It's a huge market, mobile and server market. You know, I do think that there will be a mobile cell phone based on Risc-V. I think that'll be a game changer, and I think the company that's going to be doing that is going to be doing it for the same reasons we chose Risc-V, because they want that ability to innovate. They get security from the ground up, and they can write custom instructions specifically for whatever they decide, you know, that cell phone needs to do, which is actually, you know, a cell phone is not really a cell phone anymore. It's, you know, it's a supercomputer in your hand, and it's going to be your doctor in the future. It's probably going to do everything except clean house, but you know, but it's going to be pretty powerful.
I'd be surprised if that cell phone didn't exist somewhere and we just don't know about it yet.
Yeah. Can I get one, please?
Exactly.
Yeah, me too. I've raised my hand for one too.
What do you think, Mark? You have any thoughts on that?
Well, you know, I have both the perspective. I mean, people ask me, what's your #1 goal with Risc-V? My #1 goal is proliferate cores and real products, right? And so all the things that Josh and Tim have talked about are really incredibly important. You're going to see a proliferation of development boards this year. You know, Drew is a little bit of a participant in that because he's part of BeagleBoard, and they're very involved with getting boards available. I have a goal of getting 1,000 seed boards in the hands of academics this year, and we have a program that we're working on. You know, another bunch of boards in the hands of early adopters, like Hackerspace and so on and so forth. So we're trying to make sure that the right people, not only for this generation, but for the next generation of developers, are you know, competent in Risc-V and know its values and so on and so forth. So that's one whole piece. I mean, and helping all these teams and groups and companies, you know, get through the process in order to put out, you know, a product, whether it be a honking server or a you know, PDA or something. It doesn't matter, right? It's a very big process, and everybody you know, needs to go through the work in order to make that happen. However, we've started a bunch of extensions that people want to see finished, and so for me, the next goal is to get the things over the finish line that we started. So the two, I would say, very, very visible things this year are vector, and novel things are vector, and it's going to be used for AI and ML and lots of things. You'll be surprised to see some people do some very small version of it, even in embedded situations, because they need it. And then the other one is crypto scalar, because it's very novel and nobody else is doing something like that. So just so you know, the vector stuff has, I mean, if you haven't seen it, there's a great talk that was at the summit in December by Andes, who did an implementation of it in 9 months, which is kind of record time for vector. And he gave a 3-hour talk, and it's a brilliant talk. And so it's really wonderful if you want to learn more about that. And then crypto scalar is really interesting, because if you just took the regular instructions and implemented AES 128, it would take over 1,000 instructions to go through kind of one, pass through the loop. With the crypto vector, that's going to get down to 1 instruction, but it's very expensive for some embedded folks to implement it. So crypto scalar is going to get it down to 75 instructions instead of 1,000. So it's a very novel approach. Those are 2 of, there's about 8 extensions coming out this year. Some of them very much targeted towards embedded. Some of them are general purpose. And I think that, for me, it's both, making sure those products get out, and then making sure we deliver what we need to deliver for Risc-V members.
So we have a pretty cool question from the audience. Is it feasible to crowdfund the design of an SoC? Specifically, I'd love to see there be some sort of ability for community to get involved in the specification of an SoC. However, taping out a SoC seems to be something that only companies with significant financial resources can accomplish. So is there something, is there a place for crowdfunding in this?
I'll start with that one. I think crowdfunding is you can consider it to be crowdsourcing, right? We're getting the ideas and kind of combining them, but that's kind of distinct from actually what I consider to be crowdfunding, which is raising those resources to allow a small team or 1 person or a group of selected people to actually carry out that task, right? And they can be done at the same time. I haven't actually seen it done with an SoC, but I think that the most likely route to a crowdfunded SoC is a bunch of small teams putting their ideas out there, getting them funded through crowdfunding, and then taking them through a program. I think the Skywater Foundry, for example, there's a program, a company called eFabless that's helping run that, where you can get a slot in one of 50 or so, one of 50 chips, the teams that are making chips, and that's being funded, I think, in part by Google. So there are companies with those resources that have incentives to kind of throw noodles at the wall and see what sticks, right? And crowdfunding is a great way to do that. Now, the crowdsourcing part of it, the more noodles you throw, the more of a crowd you have, I guess.
Yeah, I also, again, point to Low Risk, Open Hardware, and Chips Alliance. Western Digital donated 2 full designs of chips into Chips Alliance. And all of those are working on various pieces for SoCs, as well as for just the chip implementations. So I encourage people to take a look at that. I like cooperating communities, because as Josh said, sometimes you have you'll end up with a lot of different crowds, and again, we're about innovate, don't duplicate. So we try to have people leverage off of what other people do as much as possible. But the fact that it's even possible to do that in today's world, the fact that people are willing to do that in today's world with a technology that's this young. I mean, look, we've had people give full chips into open source before in the past, but you still needed those corporate entities to keep them alive. This is different, and so it's an amazing phenomena, and it will be interesting to see the book that's written in 20 years about it.
So we hear a lot about Risc-V and FPGAs. What do we see as the opportunity there? Maybe, big opportunity here in the electronic space, maybe it's the economics, what is it? That is a recurring theme, especially across the web. We see a lot of people asking this question.
Ton of questions on that.
Yeah.
Well, I mean, I think anybody who develops an SoC, regardless, whether it's a 50-cent micro or $500 server class CPU, at some point in time, you start prototyping in an FPGA. So FPGAs, exist where standard product and ASSPs don't, and where ideas are born and realized. And so you do see a lot of activity around FPGAs, and I don't see that, abiding or slowing down at all. As architectures are explored, I mean, you can prototype something in an FPGA, maybe try to do some fault injection or try to do some side channel timing attack, things of that nature. So I just don't see it slowing down. The economics of it, that type of activity is more of an R&D type of an activity. And I mentioned earlier that SoC FPGAs serve many different applications, and they exist because somebody has an idea that they can't buy off the shelf, so they have to make it. And the only way you can do that was with an FPGA. So SoC FPGAs are just even more versatile than an FPGA because it's now software and hardware programmable. So it'll be around for a long time.
Yeah, and I think one of the things that's also incredible over the last 15 years is how capable FPGAs have become, right? And so, whether it be, IO pins or whatever, they just have really gotten very capable. But I also want to point out that there are some complex applications out there that are using Risc-V for a very small, hidden, targeted thing because they can get a very small version of it, into it. So some may have 10 different Risc-V cores in there doing particular operations that need to be done. Really easy to do and replicate on an FPGA and get it into place. And so you may not even know that some controller out there or something has some major function, but it's got a whole bunch of Risc-V cores doing little pieces of the work because they can lay them down so quickly, because the stuff's available, and because it's effective and a good way to solve a problem.
Yeah, kind of going back to two topics we discussed before. One, security, and one is turning software developers into hardware developers. The combination of FPGAs and Risc-V are perfect for both of those, right? Like, as a software developer, as soon as you write code, there are bugs in it, of course. And so as soon as you ship a product, you need to fix it. And that's what FPGAs allow you to do. At the same time, you want the kind of library, so to speak, of Risc-V that's a known entity that you can deploy and then run your software on. From a security perspective, Tim's absolutely right? Like, the economics of FPGAs aren't great for a lot of things, but for the high security demands of, say, a hardware security module that a bank might use, it absolutely makes sense, right? You'd want to spend thousands of dollars so that you could upgrade your hardware in the same way you upgrade your software to keep your bank secure.
Makes sense. So I'd love to close out with a very future-facing question for everyone. Josh, why don't you kick us off with let's close out with looking at the path for widespread adoption and really looking into the future, and what does that path look like? We've got about 5 minutes left, so I'd love to leave the audience on that note.
Sure. Mark mentioned that there's a lot of Risc-V cores out there that we may not even know about, and that's certainly true. I think the path toward widespread adoption is actually knowing about them, right? And making it so that you recognize it. An engineer can recognize when to use it. They can use them out in the field. If they find a device with a Risc-V core in it, they know what to do with it. and then they know how to build new products on top of it. And for that, I like going back to the laptop example, it's just a matter of getting it into people's hands. So, again, Mark mentioned one of his goals is getting boards, 1,000 boards out to folks this summer. I think that's the blocking and tackling that we have to do in the near term for longer term adoption.
And Mark, I mean, if you want to piggyback on that and tell us a little bit about what we can expect as well from Risc-V in 2021, that would be great.
Sure. I mean, I think that, the stuff I alluded to before, these profiles, RVA22 and RVM22, will have a bunch of extensions along with the high profile ones I talked about. There's a bunch more. There's J, there's code size reduction ones. There's packed SIMD, again, for embedded primarily, and just a bunch more that are in the pipe. And so I think what you're going to see in 2022 is a full court press on getting the things that we have in flight, because some of those things take a long time to design. They've been at it for a year because they're tough, right? And they want to get it right, and they don't want people to implement something that they have to change later or something like that. So they've worked very hard to make sure that they're robust and that they're viable. And so you're going to see that come out in 2021 as RVA and M22. But I think Josh had it dead nailed. I mean, in the end, it's going to be more people developing on Risc-V and deploying products on Risc-V that people know are Risc-V, because I think success begets success, right? Accomplishment begets accomplishment. And that's what we really want to see. That's what we really want to help the community with. And we want to go ahead and continue to innovate and find new places. I've got, again, 2 or 3 things that we haven't even begun to talk about inside of Risc-V, about the startup groups within Risc-V to make sure that we are useful for the community and useful for the members and useful for people who make money.
And Tim, we talked a little bit about the PolarFire and Ice Sculpt kit. What about Microchip? What are you looking at down the road? Where are we going?
The only thing I could say is that the future is so bright for Risc-V that we'll all be wearing Risc-V shades. PolarFire SoC is kind of a game changer. We're fully committed to Risc-V. It enables us to innovate in ways that you can't see in the market today, products you can't see in the market today. And we're continually working on those kind of things. And one thing I might add is I think you'll also start seeing more of an explosion in the software ecosystem over the next couple of years. Now that we've got hardware out there, it's a venue for commercial middleware tool developers, real-time operating system suppliers to monetize their investments in Risc-V, and we're starting to see that.
Well, thank you so much, everyone, for joining us today. Thank you to our great panelists, and thank you to our sponsors, Mouser Electronics and Microchips. Guys, thank you for sharing your knowledge with everyone, and everyone have a great day.